Based on all of the videos I've been making over the years, I think by now a lot of you have realized that we live in a universe filled with various mysteries. Things that we just don't understand even after years and years of studies and investigations. And as the technology to observe these mysteries improves, even though certain mysteries finally find solutions, we actually end up discovering even more things that we cannot explain. And so today we're going to be discussing one such mystery that was only discovered about 5 years ago. Hello wonderful person, this is Anton, and today we're going to be discussing the mystery of fast blue optical transients, more commonly known as FBOTs, and even more commonly known as the cow. And the only reason they're known as the cow is because of the first detection ever. The first such transient discovered, completely by accident, had the letters COW at the end. And these were completely randomly assigned, but because of the unusual spelling, a lot of these events are now referred to as the cow events in general. But what exactly are these and why are they so mysterious, and more importantly, why are we talking about them today? Here's actually what the first one sort of looked like during the first ever observation back in 2018. Now, in a nutshell, these are supernova, but they're just really unusual supernova that at the moment nobody can explain. And extremely recently there was another paper that actually has officially identified something else super unusual about these events, suggesting that even the shape of the explosion itself seems to be extremely unusual and very different from anything we've ever seen. But I guess let's start with the baby steps. So back in 2018, one of the automated facilities accidentally discovered a new transient, or basically a sudden explosion really far away, that seemed to possess several unusual properties. First of all, it seemed to have increased in luminosity much faster than anything else before. It also contained a huge amount of iron, for some reason was also unusually bright in the ultraviolet wavelengths, and overall seemed to be much brighter, at least 10 times as bright, as a normal supernova. And it was actually much brighter in every single frequency: X-rays, radio light, optical light, so it was just much more powerful overall. And more importantly, it also seemed to last a pretty long time as well, with certain emissions still even observable a year after. And so because it was so fast, because it produced so much ultraviolet light, and also a lot of optical light, it became known as the fast blue optical transient. But since that original discovery in 2018, the scientists have now officially identified 4 more, with 5 such events now officially being confirmed, and several others still waiting their official confirmation. And a few of these events, because of that random letter assignment, ended up having their own nicknames. For example, we have the koala event, that then turned out to be extremely hot with temperatures over 40,000 Kelvin. We have the camel event, detected 3 years ago, CSS 161010, that for some reason was emitting a lot of mass at half the speed of light. And more recently, AT 2020 MRF, that was detected to be extremely bright in the X-rays. So bright, as a matter of fact, that it seemed to be hundreds of times more luminous than a lot of other events, including the 2018 event, and produced hundreds of times more X-ray emissions, illuminating the entire universe in the X-rays from this unusual explosion for at least a few months. Suggesting, of course, that whatever is happening here has to be ridiculously powerful. A lot more powerful than just a supernova, where a massive star explodes, leaving behind some kind of a remnant such as a black hole or a neutron star. Here, something a little bit more extreme was going on, because not only was it more powerful, but even the emissions were lasting much longer. And some of the first explanations and some of the first calculations suggested that maybe it involves some kind of a huge explosion inside an extremely large hydrogen cocoon, where a lot of the gas, as it gets illuminated by the emissions from the supernova, starts to re-emit a lot of light, creating a huge super bright formation, in some sense kind of similar to what you'd expect from, for example, a halogen lamp. But in this case, all of the gas around the explosion would be a lot denser than usual, potentially representing some kind of a really massive deposit from either the star or its companion prior to the supernova. But that's just one explanation. I mean, it is a pretty good explanation, but it did not explain everything. Certain other explanations suggested that maybe there was actually a black hole or a neutron star already in orbit around the object that was about to go supernova. And in this case, maybe this explosion was a result of some kind of a dramatic tidal disruption event, when the star basically passes too close to the black hole or a neutron star and ends up exploding as a result, instead of just being shredded apart. To some extent, this would explain both the presence of a huge cocoon around this object, and also very unusual emissions that might have lasted for at least a year. And because so many X-rays were detected afterwards, you would actually require some kind of a magnetar or some kind of a really powerful black hole to potentially explain their emissions. It's very difficult to explain such powerful X-rays without some kind of a central engine, such as a black hole in the middle. And so a lot of these individual explanations sort of made sense on their own, but they still do not explain absolutely everything that we've observed, and more importantly, they do not explain this recent detection that was just actually analyzed by another study. A study that once again focused on that original explosion from 2018. But in this case, this study focused on what's known as polarized light. And more importantly, they wanted to recreate a kind of a three-dimensional image of all of the light emitted from the central explosion by trying to recreate polarization around this particular region. Polarization in this case refers to that twisting of the light, and in astronomical observations, this is usually produced by very powerful magnetic fields around extremely powerful objects such as, for example, magnetars, or in certain cases, black holes. And so by measuring polarization from different points around this object, it might be possible to recreate a kind of a three-dimensional image of what this event, or a lot of these other events, might have sort of looked like. Now normally from these distances, we basically get something like this. This is an observation in the X-rays, and so in this case it does appear kind of circular, implying that it might be spherical. And normal supernova would be kind of spherical or circular, based on all of the calculations, and of course based on what we know about these events, and how they generally progress. But the observations from here revealed something entirely different. It turns out that this unusual event was very asymmetrical and potentially extremely flat. Flat as in non-spherical. Maybe even resembling something like this. An explosion that you'd probably expect from some kind of a science fiction movie like Star Wars. Or actually, personally, it reminds me of that explosion from the original Alien. Here's actually that scene where the explosion appears a little bit flat. Now this is interesting because this was obviously done for more dramatic effects. In theory it should have been spherical, so it really should not look like this. Yet it seems that, for some unknown reason, this particular explosion may have exhibited an extremely similar flat shape. Entirely unknown why, but once the scientists can actually establish the reasons for this, they might be able to answer the question about these explosions and their unusual origin. And so the next step now is to actually see if the other 4 explosions exhibited something similar, or if they were also unique in their own way. For example, if this explosion was very asymmetrical in one direction, it implies that this might have been a binary system where there could have been a black hole or a neutron star forcing the material to move a certain way, potentially once again confirming some kind of a tidal disruption event or an influence from very massive, very dense partner. But that's just one assumption based on current observations. And so these new observations and these new papers, instead of making things a little bit more clear, unfortunately made them even more confusing. What exactly is causing these unusual explosions to be so asymmetrical and potentially even entirely flat? And I guess more importantly, what's actually exploding here? If it's a star, what sort of a star is this? And why does it produce so much iron and ends up emitting so many X-rays? And so I don't think we're any closer to answering any of these questions. And so on that note, once there is some more information or more explanations, I'll make sure to follow this up with the next video. Until then, check out previous parts in the description below, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, and maybe support this channel on Patreon by joining channel membership or by buying the 1 person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.